Hello, welcome to TypeScript Basics. In this part, we are going to look at generics. Generics basically allows you to specify type constraints. You can specify type constraints to a class or to instance members or static members. You can also specify type constraints to functions. Before we look at an example for generics, let's take a look at the problem that we will be facing with our generics. I have VS Code open here and I'm going to create a class called a list. So this class has two methods in it. The first one is add and the second one is get. So add method basically allows you to add an item to this list, and the get method is basically used to get an item from the list using the index. And currently this list is typed to string. So we actually accept string value and we return string value when we call the get method, and internally we store all the value as string. So this is a string list basically. So if I want to use numbers with this list, it's not possible without creating a new version of this class which supports number. But I don't want to do that because that's a kind of code duplication. So the another alternative is to use any as a type. So rather than using string here, I can change this to any. Now this list supports any data type. So let's create a list actually for string. Let's call it string list, and I'm going to add a few values to it. So string list dot add, I'm going to say name. I'm going to add another value, say age. So this is my string list now. I can also create number list. So let's call it num list, and I can add values to it now using add. So I'm going to add 1 and I'm also going to add 2. So now I have two different instances of this list, and the first one is string list and the second one is number list. Now let's assume that we are using this string list in our program in a way that we get a particular value and then we call substring on the string which is returned. So let's say console.log string list.get, I'm going to get the value from the index 0, and then I'm going to call substring 0, 1. So when I run this, I'm expecting to see character n on my console, because basically we are trying to get the first character from the string returned by this call, which is going to return the first item from the list. As you can see here, it has printed character n. Now if you see here, actually, even though this get method is going to return string because we stored a string in it, I don't get any IntelliSense from the VS Code because it doesn't know the type of it, because we have used any as a data type. That's one problem. And the second problem is, if I change this to a number, for example 1, 2, 3, and if I run this, I'll get runtime error. See, I get this runtime error because number doesn't have substring method defined in it. And this is really bad actually, because with a typed language like TypeScript, you'd expect to see compile time error for these kind of things, but we are not getting compile time error because we used any as a type for this class. So how do we solve this problem? So we solve this problem using generics. What we can do is, like, rather than specifying these types as any, I can make this list as generic list by specifying a generic type. So I can specify generic type to this list using angle brackets. So I'm going to put a pair of angle brackets, and within that I'm going to specify that it's going to take one type parameter, and I'm going to call that type parameter as t. So basically what I have done now is, like, I have changed this class to take one type parameter, and we'll be specifying the type parameter when we create an instance for this class. Now, because we have this type parameter, I'm going to say the private items that we have here is going to use the t as a type. So rather than any, I have replaced that with t, and I'm going to do the same for this and this as well. So with this, we are basically saying whatever type I specify here is going to be used in all these three places. So now if I change this to take string as a type parameter, then when I try to add number to it, I get compile time error. This is good. This is what we want. So this basically prevents the runtime error that we were getting previously. So if I change this back to name, everything will be all right. Similarly, I'm going to change the second list, which is number list, to take number as a type parameter. So now if we try to put anything other than number, for example, a string, then it won't let me do it because the list is strongly typed now. This is generics. If you want, you can add any number of type parameters separated by comma. So let's say if I want to add another type parameter, then I can add them separated by comma. I can add any number of type parameters. Let me remove this. We can also specify these type parameters directly to the function. I'm going to remove this, and internally it's going to be any items. But here what I'm going to do is I'm actually saying that this add method is going to take a type parameter, and that's the type I'm going to use for the parameter. And then when I get the value, I'm going to say I'm going to get the value as k, for example. And then I'm going to specify type parameter for this get method as well. So it's going to take type parameter, say called k, and that's the return value of this get method. So I'm going to change this to k. So now, rather than specifying this type parameter at a class level, I'll be moving it to the method call level. So I'll specify this as string. The thing is, I don't need to specify this explicitly because TypeScript is good enough to infer it from the value that we pass. So if I hover over this, you can see that it has inferred its type as string based on the value that we are passing. And then for the get method, because we haven't specified any type, it doesn't know what's the value it is returning. So we have to specify the type for get method explicitly because it's the return value, and it couldn't infer the return value. So if I specify this as string, then everything will be normal and it will give us the same result that we were getting previously. But here there is a big difference. In the previous example, we have defined the type at class level. Because we have defined it at a class level and we had only one type parameter, and the same type parameter is used for both add and get method, they both will always use same type. But now we have moved it to a method level, and at the method level we could use, say, string for add and a number for get. In this particular case, it didn't make sense, but it basically shows that you can have type parameter at a method level. We can also have a type parameter for static members. So if I change this to static, it will still work. In this case, I can't access instance member from static, so it complains. So basically, there is no difference between instance method and static method in terms of generics. You can't use generic for static property. So if I have a static property, say test, I can't specify the type of this property as generic type, say R, because it don't accept it. So it's not possible. So basically, for a static property, you cannot have generic type. We can also use generic types directly on a functions. Let me get rid of all of these. Let me create a function. I'm going to call this function as print, and it's going to take a generic type t, and it's going to take, say, a parameter called value, and it's going to be of the same type t. It's going to return void, and within here I'm going to say console.log value. This function is not basically using any features of generics, but I'm just creating this to demonstrate that you can use generic types on a function as well. So if I call this function with string value, then it will infer the type parameter as string, as you can see here. If I change this to number, it will infer the type parameter as number. So this basically shows that you can use a type parameter on a functions as well. You can also explicitly specify type if you want, but in most cases, if you use the type parameter for parameter as well, it will infer them. If you want to specify more rules to this constraint t, then you can do that. Generally, we would do that by defining shape of the type that we want to accept using interface, and then we say this type t basically extends that interface. So let me show you what I mean. Let's say we want to accept the types that has a property called value in it as a type parameter here. So basically we can do that by defining an interface which has value property in it, and then specifying that this type T extends that interface. So let's create an interface called printable, and it's going to have a property called value. It is going to be of string type. So now I'm going to say that the type T should extend printable. So by doing this, I can only use any type which has value as a property in it for the type. So as you can see here, because number doesn't have value as a property in it, the compiler complains saying that it's not compatible. But if I create an object, say color print, and it's going to have a property called value, let's say RBG, then if I use this object here, everything will be okay. Let me remove this as well because it will automatically infer the type. So now everything is okay because this object color print has value as a property in it, so which is in line with this rule, so which is fine. If I change this property from value to say value 1, then I'll get an error because now this object doesn't have value as a property in it. So this is how you specify more rules to the type constraint. So that's it for now. I hope this video is useful. I'll see you in the next video. Thank you.